Hey, how's it going? Hi everybody, I'm Mr. Rowdy, and you're here for a math lesson, and I'm here to give you one. Today's lesson is order of operations with powers. So, having said that, let's go ahead and get started. Okay guys, to start us off in our lesson on order of operations with powers, let's go over today's objective. Today's objective is to be able to solve expressions that include powers. So this is what you want to be able to do by the end of the lesson. Now, let's review a couple of terms that are key to understanding order of operations using powers. First, got to remember that a numerical expression is a combination of numbers and operations. We often refer to math problems that we're used to seeing in our textbooks as problems. Well, really, from here on out, we're always going to refer to them as expressions. Powers are a simple way to write an expression that multiplies the same number over and over again. You probably remember this term from our last lesson, lesson number 2. Numerical expression is one that we got introduced to in lesson 1. Keeping those in mind, let's go on to a little review of order of operations. Back in lesson 1, we covered order of operations when we use multiply, divide, add, and subtract inside the numerical expression. Now, when we have these type of operations, we first start by multiplying and dividing left to right. Doesn't matter what comes first, multiply or divide. We start on the left, work our way to the right, doing all the multiply and divide. Then, second, we add and subtract left to right. In this lesson, we're going to add in this idea of powers that we covered in lesson 2 into the order of operations. So when we solve an order of operations problem with powers, we start out, instead of doing the multiply and divide, we start first by finding the value of all the powers. So we go through the problem, identify all the areas or all the parts of the expression that have powers, and find the value of those powers. Then we continue on like we did before, and we multiply and divide left to right, and finally add and subtract left to right. So let's take a look at some example problems that have powers included in the problem. So we're going to start out with our first problem, which is going to be 2 times 5 to the second power, or 5 squared, plus 10 squared divided by 10. So if we're following the order of operations that we just looked at, those rules, the first thing it said for us to do was to identify and find the value of all the powers. So I'm going to go through and find all the powers in my problem. So I've got 5 squared and 10 squared are my two values or parts of my expression that have powers. 5 to the second. Now if I remember back to my previous lesson, 5 to the second is the same as 5 times 5. So that gets me a value of 25. 10 to the second is the same as 10 times 10, which would be 100. Now I'm going to bring down everything I did not use, which would be 2 times 25. I keep the plus sign, and I keep the divide 10. Next step is I need to use all my multiplication and divide left to right. So I'm going to locate my multiply and divide. I've got a multiply here, and I've got a divide here. And I'm going to work my way from left to right. So 2 times 25 gets me 50. And 100 divided by 10 is going to get me 10. The only thing I've got left to bring down is my plus sign right here. Now you can see why showing my work would be very important. I've got a lot of things going on here. If I skip one step or do one thing in the wrong order, I'm going to get the wrong answer. So it's always important to show each step of your work. 50 plus 10 is going to equal 60, which will be my answer. I have no more operations to complete in this expression. Let's look at one more. How about, for this problem, we do 5 times 2 to the third times 3 minus 10. So, let's start out. We identify all of the powers in our problem. In this problem, I've got 2 to the third, and that's my only power, so I'm going to do it first. 2 to the third is the same as 2 times 2 times 2, which 2 times 2 is 4, and 4 times 2 is going to get me 8. So, I have 8. Bring down everything else, so 5 times 3 minus 10. Next step, multiply and divide left to right. So I've got a multiply and a multiply. We'll just start left to right. 5 times 8 is 40. Now 40 times 3 is going to get me 120. The only thing left to bring down is my minus 10. Now I've got 120 minus 10 equals 110, and there's my answer. Let's take a look at a word problem you might see that uses order of operations. An example would be, let's say we've got a large cookie and it had 6 to the third power calories. I know that seems a little odd. Normally we'd just say exactly how many calories it has, but hey, it's a word problem. 6 to the third power. We have an ice cream cone that has 4 to the fourth power calories. Now, here's our question. What is the difference in calories of the two desserts? In order to know that, we've got to subtract. The reason we know to subtract is because it uses that word difference in there. Anytime you hear that word difference, that's our cue that we need to subtract. So 6 to the third minus 4 to the fourth will tell us the difference in calories between these two. Now, right now, this doesn't mean much to us because 6 to the third and 4 to the fourth aren't the exact values. So what we need to do now is find the exact value for 6 to the third and 4 to the fourth. 6 to the third is going to look like 6 times 6 times 6. So if I do 6 times 6, it gets me 36. 36 times 6, we're getting a little bit bigger now. If we multiply it out, 6 times 6 is 36, carry the 3. 6 times 3 is 18, plus 3 is 21. So we get 216. 4 to the fourth, if we go there, is 4 times 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. And bring down that last 4. 64 times 4. And we times that out. 16. 24 plus 1 is 256. If we subtract these, 256 is going to get us a difference between these of 40 calories. Now the way we're subtracting there, we're going to end up with supposedly a negative number, but we just want to know the difference in calories. So we subtract the bigger number from the smaller number and we get a 40 calorie difference. Well, that's our lesson. Thanks for watching. Have a great evening.